What's up, math scholars? It is Monday, and we're pretty excited because this week we have 2 lessons to learn about, and then we're going to review and take a quiz Thursday. So who's excited about 10 too? Yeah! Woo! First things first, we're going to take our sine and cosine graphs today. Only sine and cosine, not tangent today. And we're going to be shifting them left and right and up and down. So just like we've been doing, honestly, since chapter 1, you'll have a number in parentheses with a minus sign. That's going to be your left-right shift. So just like it's been this whole entire school year, it's going to be challenging. Because if you see a minus, it'll be a left shift. I'm sorry. If you see the minus, it's a left shift. No, I'm saying this wrong. So let me give you an example. I'll need to see an example. Alright, so if you see that 5, the minus sign is part of the formula. So this would actually be a right 5 shift. Okay? And if you see the plus 7, that would be an up 7 shift. So that's your left right, and that's your up down. And then your A will affect the amplitude, just like it did on last Thursday. Amplitude. And that's going to be your B value, which will help you figure out your period. Okay? So H is left, right, K is up, down, and A and B are just like always, amplitude, and the B will help you get your period. You don't need to write down the blue and the purple box. They're pretty much the same thing. One is sine and one is cosine. I did go ahead and add circles on here that it would be 5 right and up 7 for this case. All right, let's talk about what a word midline means. A midline is an optional thing that you can draw in. It will help you kind of keep everything aligned. But it basically is drawn in at y equals k, and k is your vertical shift amount. So in this case, this graph, it looks like it's a sine graph. How do I know? It starts at 0, goes up first and make a mountain, goes down and makes a valley next. It looks like this sine graph has been shifted up 3 units because its midline is running across at 3, where it used to be running across at 0. Do you see that? So it's an optional thing that you can draw in just to kind of keep everything aligned. Make sense? That's a midline. This would be a vertical shift of 3, up 3. All right, we're going to try a few of these. Here's going to be our strategy. I'll just kind of write my strategies off to the side. Our strategy is we're going to draw in what this graph looks like before the shift. And we'll draw it in real light pencil. So in light pencil, draw in graph before the shift. Then you'll perform the shift and highlight your answer. I told people if you have a highlighter with you, that'd be awesome because you'll have this light line drawn in, but then you'll have a highlighted line that we will know is your final answer after it has been shifted. I like to start by identifying A and B, and then identifying if there is any shift at all. So A, 2, B, 4, and then is there any shift at all, horizontal or vertical? Which one? Vertical shift, it's 3 up, and there's no horizontal shift, so that'll keep things easy. So we know it's 3 up because that plus 3 at the very end. Alright, since this is a sine graph, the amplitude's real easy. It's just going to be a 2. So my maximum point will be up at 2, and my minimum point will be down at -2. That's before the shift occurs. In my period, there is a period formula for sine and cosine graphs. Period. It's 2 pi over b, so 2 pi over 4. What would that simplify down to? 1 pi over 2. So we have to kind of really think in our memories to last Thursday. Last Thursday, we would talk about going out 4 hash marks and making this 4th hash mark our period. So that's a pi over 2. And then if you remember, we would cut that number in half, and then that would be our 2nd hash mark. Cutting something in half involves multiplying by 1/2, multiplying by 1 over 2. So do you know what this is going to be? Good, yeah. Cut it in half again. That's your first hash mark. Perfect. And do you remember how to get the third hash mark? Right, triple your first hash mark. So take your pi over 8, multiply it by 3 over 1. So 3 pi over 8. All right, so we're about to draw in what our sine graph would look like before the shift. So at this point, you're using really, really light pencil. This is not our final answer. This is just what it looks like before it shifts up 3. Okay, makes sense? So we're gonna, I don't have a light pencil capability on the smartboard, so I'll just use pink. We're gonna start at 0. We're gonna end at 0. That's what sine graphs do. We're gonna hit our maximum peak at 2 at the first hash mark. We'll be back to 0 by the second hash mark. We'll be down at -2 by the third hash mark. And we'll be back to 0 at the end. So this is light pencil. I'll just use a dotted line. Really light pencil. It's a snake. It's not a snake, it's a sine wave. A sine wave. It's a sine wave. We're on recording. We're recording, everyone. Okay. We're about to do our vertical shift of 3. Now here's where you can use heavy dark pencil or even highlighter to highlight your final answer. Every dot gets shifted up 3. 1, 2, 3. This is my brand new final resting position for that pink dot. This one was at 2. Now it's going to be up at 5. And this is where that midline can be helpful. Your midline will run through 3 now. And that can kind of help you up. My second hash mark, I'll be back to my midline, back to 3. And then this will shift up 3. It's at 1, I believe. And this will shift up 3. Back to where we started. And so you can make this in heavy dark pencil and even highlight it, because that's your final solution. Awesome? Drawing is the struggle.
Drawing is the struggle.
All right, we found ourselves a cosine graph to practice, so go ahead and jot it down. All right, we'll identify our A and B, and then we'll discuss if we think there's any shift. What do you guys think A and B are? 5 and 2. B always lives kind of out front of any parentheses that would be there. So we know our amplitude is 5. We know our period formula is 2 pi over B. So 2 pi over 2. That's going to be pi. What are you guys thinking about shifting? Any shifting occurring with this? Horizontally 3 pi. Now will it be 3 pi to the right or 3 pi to the left? Very good. 3 pi to the right. So you can kind of see I already have a pretty long line drawn out. That's like a little information that we're going to be headed to the right. And vertical shift? None. Okay, so we are going to number 4 hash marks out. We're drawing what this graph would look like before the shift occurred. 4 hash marks out would be pi. So we cut that in half. It's pi over 2. Cut it in half again. Pi over 4. Triple it. 3 pi over 4. Do you guys remember from last Thursday what a cosine graph looks like? Starts high, ends high, looks like a big bowl, right? How high up will I start? 5, because the amplitude is 5. Very good. So I will go up 1, 2, 3, 4, 5. Our starting point will be at 5. And then we will dip down to -5. And then we will come back up and end at +5. So again, this is really light pencil. This is what it looks like before any shifting occurs. And then we will have to perform a right shift. This shift's actually going to be really big. I might not even have enough space, huh? Hello?
Are you going to give us a graph?
Like enough space?
Or are you going to draw a graph or are you going to draw?
You'll have to do exactly what you're doing here. You'll have to do the graph and answer a few questions.
I mean, like you're not going to provide it.
I'll provide an X and a Y axis with some hash marks, but it might not necessarily be enough. Like here, I did not provide enough hash marks. We need to keep providing. So 1, 2, 3, 4 hash marks, that's 2 pi. 1, 2, 3, 4, that's 3 pi. 1, 2, 3, 4, that's 4 pi. So you just kind of make do. Yeah. Oh, period is, we have a formula, 2 pi over b, that's what I'm doing up here, I just didn't label it. 2 pi over b is 2 pi over 2, so the 2's cancel, it's just pi. Here's what I thought Ethan was going to say, because Ethan is a scholarly guy. If you take all of these points and shift them 3 pi, guess what's going to happen? Let me take this and shift it forward 3 pi. 1 pi, 2 pi, 3 pi.
I was thinking that.
1 pi, 2 pi, 3 pi. You know what it's going to be? It's going to be the same exact curve, and it would have connected all the way through. So really, that shift didn't affect it at all. It's the same exact graph. You see it?
Yeah.
It took this graph, shifted it over 3 pi, everything would still connect. It wouldn't become misaligned from where it is now, which is cool. So basically what we had could have been our final answer. Do you see that or not? Yeah? All right, I'll pause it and let you kind of finish your drawing. How large should we make it? Well, you can kind of look, Carly. How far up and down is this going to go? This will shift down 1. How far left and right will it go? Pi. So we don't really know how big pi will be yet as far as how many hash marks it'll be. So we will find out. All right, who knows what A and B are? This is a tricky question. Uno. He's right. Invisible 1 for A, invisible B is 1 as well, because there's no number out front of sine, and there's no number in front of the parentheses. So our amplitude is 1. I'm going to have Ethan help me. Ethan, where are you at? What's our period formula?
2 pi over b.
And B is 1, so what's our period? Good. So we need 4 hash marks. 1, 2, 3, 4, and then that will be 2 pi. So that's 1 period. Yeah, that was last Thursday. Cut in half, he's remembering.
Yeah.
Cut in half again. And triple it. Yep. I'll kind of pause. We got going real quick there. Don't want to lose anybody.
No.
All right, so we're going to go up 1, down to -1, because those are our amplitudes. What? We're doing sine, right? You remember what sine looks like? Starts at 0, ends at 0. Makes a mountain, makes a valley. And we draw in really, really light pencil because we haven't done any shifting yet. This is kind of a challenge when doing the shifting on this one because we have a horizontal and a vertical shift, but we'll get through it. Guess we should discuss this. I verbally discussed it with Carly, but it's down 1 for a vertical shift, so we are going to have to go down to -2 with our numbering. She asked me before we started how big should we make our axis, so we do need to go down to -2. Hey, we'd actually probably need to go down to No, -2 would be fine, yeah. And then what's our horizontal shift going to be? Pi units, but that is pi left or pi right? Pi to the left. Which it looks like to me a pi would be 2 hash marks. So we're going to do 2 hash marks to the left. This would be -pi/2, and this would be -pi. And how do I know that? They're just reflection images about the axis. Okay, we're ready to do some shifting. So every single dot, we have 5 dots. Every single dot will get shifted down 1 and left 2 hash marks. So I'll just go real slow. This dot, I'll move it down 1, left 2 hash marks. So this is the final resting position. If you want to draw on a midline to help your visual interpretation on this, you can. My second dot, if I go down 1 hash mark and left 2 hash marks, it will be here. So far, this is how far I am. My third dot, down 1 hash mark, left 2 hash marks. There's he at. There's where he's at. Down 1, left 2, probably about here. And down 1, left 2. These just take so long. That's why this is going to be our last problem, okay? So my blue is what I would want to highlight. My blue is what my final answer is after the shift. Fun? Any questions? All right, I'll hit pause. Thanks for watching the video at home, guys. The homework is a worksheet that if you need to find it would be at the very end of the PDF of the notes that I've got in Polaris, okay? Have a happy, sunny Monday.